So I'm starting the recording, just going over a few questions. Yeah, okay, so that's what I figured about the magic function. Passing a pointer as reference make it a pointer. So it is actually just a pointer. If by reference, do you mean like putting an ampersand in front of it? Yeah. So the ampersand operator, you're right, gets a reference to the thing. A reference is actually another name for a pointer. So when you use the ampersand operator, it's actually getting the address of the variable that you're using, and because that's a pointer already, when you get the address of it, you're getting a pointer, which is the address to that pointer. So it would be a pointer. So I guess yeah. Oh, sorry if you can hear that motorcycle doing like sick donuts in the parking lot. But yeah, the ampersand returns the address of the thing. And the other question was, when we assign assignment 5, do you only want some files zipped? Yeah, I guess just the AST5 and the Skynet.cpp, and then I guess also runner.sh would be nice to have, just so I don't have to like copy that over, because it kind of like separates all the students into like individual files or like directories. Right, so I guess we'll get started. So exam is on Wednesday. It is going to be at the normal class time. It's going to be on Canvas, so we're not going to show up here at WebEx. You can just go straight to Canvas and take the exam, and it should be there. I'll probably try to get it posted either tonight or tomorrow afternoon. Maybe just do it during my office hours, I'm not sure. So I was looking over some of the questions that the other instructors wrote, and I wanted to go over some things that I noticed were in there that we either hadn't gotten to yet, or that I just wasn't using terminology, or just things that I guess I just didn't think to cover. Just so that if it ends up showing up on your test, that you maybe have some sort of idea of what it means. Now, unfortunately, with the way it seems like the test importing works, I don't think I have a whole lot of control over the questions itself, or themselves. So I believe the way it works is that everybody's going to get their own separate test pool that's going to be about the same difficulty. It's going to be based on a pool of questions, and that's partly just to prevent any sort of cheating, since it's entirely online, is to make it so that not everybody gets the same question pool, but you do get the same topics, I guess, is the idea, and they are generally weighted, so hopefully it should be about the same difficulty. Now I'll see if I can at least like maybe prune questions if it lets me that I know I didn't do a whole lot covering on. But yeah, I'm going to at least try to cover everything that I saw in there, just so you have an idea. And there is a list now I just posted a few minutes ago on Canvas of all the topics that are going to be on that test. At least I saw. Right. So the first thing I saw on there was friend functions, which I was planning on covering next week. But we'll just throw it quickly in here, and then I'll go into more detail next week. So what I've done is I've reopened this operator overloading thing, which I was going to go into more detail on next week. So just as a reminder, this had like a class that was a fraction. I think that's pretty straightforward. So it had like a numerator, denominator, and then we were just giving it the ability to multiply and then probably like add and divide later. So we had something like this where it was multiplication. So here you might notice that I had an operator, and it was a static fraction operator, and it shouldn't have been part of the class itself. I'm not sure what that's about. So this multiplication operation was not a part of the fraction class. It was at the global scope. And so because of that, I'm not able to access the numerator or the denominator directly, because I'm not in that class, right? A private variable can only be accessed within a class, or in the class that it is private to, and not in derived classes, and not outside that class. Now what you can do, so that's where a friend function comes in. What you can do is you can say friend, and then give the name of a function that you want to be at a global scope. So in this case, the friend here should be the operator, and then times, and we should need to put this here, and that should be okay. Invalid friend. Is my syntax on this bad? I'm gonna have to look into it later. Let's just try this one. Friend void print. Oh, you know what? I didn't even put an argument list. That might be it. Fraction 1, fraction 2. There we go. Yeah. So I've redeclared this operator. So you can put a friend in the, and I'll explain the syntax more later. I guess it's just more important what it does. So I can declare it here, and basically say friend function, and then write it later. And so what this function is, it's not actually part of the class, which means I don't need to have a class instance in order to use it, plus it's static anyways. So I can use this in main, just like, you know, a times here, or I could have called the function normally if it was like a normal function. And now it has access to private variables. So I could say, instead of get numerator, like an accessor there, I should be able to do that. Maybe I need to put friend here as well. No, I thought I knew the syntax. Maybe I don't. Sorry, let me just double check on what that is. Member function. So we have friend void. No. Maybe it's because I didn't put the static part. Does that fix it? Ah, there we go. No. Fraction has no member. Oh, no, it's just because I can't spell. Just sitting here thinking I don't have the same syntax. It was called numerator in this fraction class. So we had this this private variable numerator and denominator, and then I originally wrote accessors for it, so get numerator, get denominator. But now that it's a friend, I actually have the ability to just get it, even though it's a private variable. Numerator. And then so on, and then for the sake of time, I'll just talk about this more next week. But the idea of a friend function is that it is it's a static. Well, it has to be static. It's a static function that has access to private variables, even though it's not actually a member of that class. So it has friend privileges in that it can access things that other things are not usually able to. Does that make sense, at least what it is? I'll explain it more next week as far as the syntax and related to this, because next week we're going to talk about overloading a little bit more. Okay. I'm just going to drop that out really quick. So the other things I noticed were mostly just terminology that I guess I haven't been using a whole lot, but maybe are important. So the two that I saw on the test that people wrote questions about, so you might want to know these. Hint, ADT. That is a abstract data type. And that's just a term for a data type that's essentially like non-primitive. So it's not something that the system necessarily knows about. So one example would be what we just wrote here: a class fraction. That is a ADT, int numerator. I'll just put num and excuse me. And we'll just say den for denominator. So if I declare like a class or a fraction, those are not types that are defined by the system by default. I guess I should make this a capital. Right. So this is an abstract data type. It contains a bunch of things together, and it's not something that the computer knows how to handle directly, if that makes sense. Like, there's no chip in the CPU that handles specifically fraction classes or specifically like, person classes, if I was to write that. It doesn't know what that means inherently. So it's abstract in the sense that, it's like an abstraction of data. It's a way to group things together, which I guess that term would be aggregate. The actual putting things together, that's aggregation. But I haven't seen a question about that. But it might be nice to know the term. Any questions on that? That's just one terminology, or one term that I haven't been using a whole lot, but might be important to understand here. So any class or struct is an ADT. Those are really the things that we use in object-oriented programming like this. And I guess I've been throwing out that term a decent amount. So if you see me ever write OOP, that's object-oriented programming, which is the idea that we store things in like classes that are able to interact with each other, or structs. So we kind of put the data all together. We make objects, which are like the variables for classes, the instances that we've been talking about, and you use them to store individual data. So I could have a person that has a name, and I could have like several persons, each of which have their own individual name that belongs to them, and those are the objects. So the idea here is that the programming is centered around the fact that you have objects to work with, so like classes and structs. And so C++ is somewhat of an object-oriented language. It's strict focused, but it is capable of object-oriented programming, and pretty much every language nowadays has some sort of support for object-oriented programming. At least the popular ones do. Right. So the last term that I saw in there was polymorphism, which is another fairly popular term having to do with object-oriented programming. And that's just the idea that things are polymorphic, which just means, so if you know a little bit of Latin here, poly is many, and then morph is, like change, might be one interpretation of it. So it's the idea of something to change into many forms. So an example of that has been the the game that we've been doing here, with the game object class and the player, and then something like enemy, and then we could do something like item. So the game object here is polymorphic in that it takes on many forms. So the game object could be an item, it could be a player, it could be an enemy, and it could also take in many forms in terms of its actual variables, like the ID or the name or what have you. So polymorphism is just its ability to take on a bunch of different forms and not always be the same thing every single time. Which is one of the good things about object-oriented programming, is that we can change the way we handle data and think about it at a higher level, than just putting some ones and zeros through some electric gates and all that. Is polymorphism a result from inheritance? Yes, but I sometimes see it refer to just like the ability for variables themselves to change. It's a very vaguely defined term. It really just many forms, I guess, would be the idea here. In this case, yeah, there is polymorphism as a result from the inheritance, although the term itself can mean a lot of different things, and I see people kind of just throw it out as like a catch-all term. But you'll see it thrown around a lot. I think that's the best example. But yeah, it could mean a lot of things. Unfortunately, a lot of these object-oriented programming terms are kind of weakly defined. And you'll find that with some things in computer science too. It took me years to figure out, or at least a year to figure out what the word hard meant, because that's a really bad term. But you'll worry about that at some point. It's not fun. Any other questions on either of these terms, the polymorphism or the ADT? Or OOP, I guess. I didn't see any questions about OOP, but I might even throw one in there because I think that's an important term. Right, and so the last thing I saw on there that I didn't cover, which you might have talked about in 135 or maybe read somewhere, is the difference between syntax and semantics. So syntax is what I would say the form of a language, and the semantics is the meaning of an expression in that language. So an example of that would be the for statement. That looks like this. I'm going to put some syntax or some like terminology here, or what's the word? I don't want to use the word syntax because I feel like that's redundant. Notation, I guess. Some notation that we haven't talked about yet. Well, we won't talk about in this class, but initializer, we'll just say initializer. Make that a little bit better. And then bool expression. And then I'll just call this post expression. So the way a for statement looks is that it always has for and then some line of code maybe that does initialization, or you can leave it blank. A Boolean expression maybe, or you can leave it blank and then a post expression. Actually, you can't leave the Boolean expression blank. That needs to be there. The other two can be blank. So it's, something like for int I equals 0, I less than 10, I plus plus, and then brackets. That's syntactically valid. So this follows syntactically valid. This follows the rules of the syntax of C++. It does for semicolon, semicolon, with an expression maybe, end parenthesis, brace, brace. And the braces are also optional, I guess, so that would be valid syntax. But the idea here is that it follows some sort of rigid rules about the way of the language as is written. So an example of a syntax error would be something like for int I, and then I don't put anything there, I guess, and then I put, let's do something stranger than this. Int I equals 7, delete pointer. No, that'd be a semantics error. Let's just do something dumb like this. For int I equals 7, and then we just throw nothing after it. That is a syntax error because I didn't put all the expressions. I didn't put the semicolon, and I don't have braces. Now the braces, again, not necessarily part of the syntax, but does that make sense why this is a syntax error? Or potentially, maybe if I just didn't put that there, maybe it's a little bit more clear. If I forget like a semicolon or a brace or a parenthesis, and I don't follow the way that something is written, then that's a syntax error. So it doesn't follow the form of the language, or it doesn't, it's not well formed. It doesn't, have all the symbols necessary to make the statement, if that makes sense. So do syntax errors essentially not allow you to compile in the first place, but semantics do sometimes? Yeah, you're on the right track. Syntax errors will never compile. Semantics errors will sometimes compile, and I'll give you an example in a second. So semantics, I guess, are somewhat subjective. There are semantics errors that the compiler can check. Unfortunately, it's a little bit harder to do that in C++ because, especially for this example, because of the way it treats booleans. Yeah, syntax will have to do with the way it's written, and you can have issues like that in English too, because English is a language. So you could say something like, "I is going to store." That's semantically syntactically wrong. Now, semantically wrong is up to interpretation in something like English. Just that would be like, what did the person mean when they said the thing? But hopefully this is clear that that's not like a well-formed English sentence. That's this would be wrong tense. I am going to, and then there's like no the here, so you're missing the article in front of it. So this is just not like a well-formed sentence in English. It's syntactically wrong. Versus semantics, which is the meaning, which could be a compiler error, maybe. It depends. So here it's with this example with the for, it's maybe a little bit harder to do that. But I could do something like, let's just say I have a person class with like a name and age, person. That's a lowercase, if that's not clear. And then I could say something like person equals 4. Now that is a semantics error. And that is one that is going to generate a compiler error. Because what does it mean to set a person equal to 4? That doesn't... What? That doesn't make sense. You could set like the age of the person to 4. You could potentially set the name equal to 4, I guess, if you really wanted to, and you like turned it to a string. But it doesn't really make sense to make like an integer into a person. That's just not syntactically valid. So something like type matching, which again C++ is very, very loose about. Sometimes it will just let you put types wherever you want that don't make sense, which is why I didn't use this value, because the Boolean expression is allowed to be pretty much anything in C++, which is a little strange. You can put integers there, as I'm sure some of you have found out, maybe accidentally. You can put integers there, you can put pointers there, and it will just say as long as the pointer's not null, then it's fine. Yeah, it just treats the Boolean as a number, which is not particularly great, honestly, that it does that, in my opinion. But yeah, those are all semantically, or as far as the compiler is concerned, they're semantically fine, but maybe to you something like that wouldn't be. So I guess we can use that as an example of a semantics error that would be compilable. So I could say int, I hope if I actually wrote the right syntax first, int I equals 0. I guess one thing too, in order to have a semantics error, you already have to have correct syntax. You can't have incorrect syntax and then incorrect semantics, because the syntax defines your statement first off, and then the semantics is the meaning of it. So for an int I equals 0, if I said I, just say that I++, this is allowed. This is syntactically valid. Semantically valid as far as the compiler is concerned. And then from a human perspective, it's just like, what? What do you mean? So so this part here, right? That's normally like I less than something, or some sort of Boolean expression that returns true or false, but this is just a number. For some reason, the C++ compiler is fine with that, as long as it's some sort of numeric type or pointer, I guess. Most other languages won't allow that. It has to be a Boolean expression. So this will work as long as I is not 0, which it will always be. Well, actually, it will never be if we start this forward loop with the initialization. But that's not like readily obvious, and maybe it's not what you intended. Maybe you wrote the wrong thing here. So semantics errors are very hard to debug because at least if the human semantics error, because the compiler thinks it's semantically correct, but you don't, and so you have no way to really tell, and that's what a bug is, I suppose, is that you have some sort of human semantics error where it doesn't do the intended thing, or maybe it just looks strange. I guess I would still say is a semantics error, but maybe that's not always necessarily true. So is that all okay, or any other questions on that? I don't typically think we cover this in this class, but I figured it might be important just because somebody asked about it on the test. I would say I would usually leave this for compilers to talk about, or 326. Oh, they did cover it in 135? Okay, that's good. Normally I would think it would be covered in programming languages. Alright. Well then, that's all I had as far as stuff I wanted to go over. So, does anybody have any questions on stuff that you want to go over for the test in particular? And if not, I'll just kind of go over everything I have on a list, but I kind of wanted to do any specific things first. Oh, did I accidentally post that twice? Could you maybe go over void pointers? Yeah, I can do that. Oh, what was aggregation? Yeah, I'll go in order. Here is the list. It's on Canvas. I'm not going to keep it. Oops. Hopefully, longer on the screen than that. But I'm not going to keep it on the screen for too long. If you want to see it, it's on Canvas right now. If you want to look over what's there. Right. So I'll just go in order. Oh, how much coding will be in it? Probably, I don't know. It's again, it was randomly generated, so some people might get 0 coding questions if you're that unlucky, and some people will get maybe more coding questions. Right now, I'd say it's maybe 10% distribution, if I had to make a guess. But most of them are not particularly long. Most of them are like 4 lines. I think there's only like 1 or 2 questions that are actual like programming questions. So aggregation, that is just this here. It's the idea that we aggregate data or like throw it together. So here I've put a fraction class with a numerator and a denominator. The numerator and denominator are aggregated into a class. They're grouped together. Aggregation and grouping, I guess, might be the same word here. So it's the idea that we, instead of just throwing a bunch of integers and booleans and all of that into main and just letting itself sort it out, we kind of put it into one package in the form of a class or a struct. And then, yeah, go over void pointers for sure. Sweet, so it seems like that's okay. And then a void pointer is just a generic type. So what we had, I think, when we did it was something like this, where it was, there's RAM and then there's a memory cell, or like all these bytes, and maybe I have something here where it's just some binary, and then all of this is the same thing. So if you remember, this won't be on the test, but an integer is 4 bytes. So any of these 4 blocks of of data here could be interpreted as an integer. Now the question is, where do I start counting from? So if I had a pointer here, then the integer would be these 4 blocks of binary. They would all get put together, put into a register in the CPU, and then handled as an integer. But if I had a pointer to here, then it would be these 4 blocks all put together and interpreted as 2's complement in the register, as far as math goes. So when I have a data type, then where I'm pointing is something that matters. Well, I guess that always matters for your pointer. But when I have a data type itself, that determines how much data I interpret and the way I interpret it in. So an integer is generally 4 bytes, and it's done in 2's complement, which you hopefully remember from CPE 100. Whereas a Boolean should be, I don't know how C++ does it, it should be just 1 byte. So if I had this pointer here where it was a Boolean versus a integer, then the Boolean would be this right there, and then the integer would be these 4. So in these cases, and I guess just in general, the type of your pointer actually matters as far as how you interpret the data that's at that memory address. Now when I do a void pointer, and that's kind of like a wild card, it can do anything. Or rather, it does nothing, I guess would be a better way to think about it, which means it has the potential to do anything. So it's a less strict version of it. So if I was to have addresses here, let's just say this is hex 04, hex 05, hex 06, hex 07, hex 08, and I had a integer pointer called x, and I set it equal to 5 for some reason, and then it goes here and it says, okay, I'm going to make that pointer. So the memory, right, just it randomly allocates this. So let's say x is $x, the address of x that it assigned was 4. So it made that variable, it went and it pointed here. Now if I go to interpret that data, and I was to say something like C out the, that's the wrong direction. C out the contents, which is the star, right, of x. Then what this does, as far as the compiler is concerned, is it says, okay, I'm going to go to the pointer, which is address 4, which is right there. I'm going to grab those 4 bytes because that's what an integer is, and then I'm going to interpret them as 2's complement. And that's totally fine. That's what we expect it to do, and we don't need to worry so much about those technical details as much as it's going to that location and it's getting the contents there. Now, if I wanted to just get the address of that x, but I didn't want to interpret it in any specific way, that's where a void pointer comes in. So if I said v pointer here, and I said it was equal to x, then what that does is it sets v pointer equal to 04. So it's really just a generic pointer that points to an address, just like any other pointer does. But the difference here is that it doesn't have any specific type. So if I tried to do cout star v pointer, or any form of thing that has star in front of the v pointer, that's an error. That's not good. And the reason being is because void pointer has no type. It's just the pointer itself, just stores the address. So it's really like any other pointer. It just, you can't dereference it because it has no specific type. Now what you can do instead is you could give it a type. So I could say cout star, this looks a little convoluted, but int pointer v pointer. So what this does is it casts v pointer to an integer pointer, which again doesn't really change anything about the pointer itself because it's still just pointing to some memory address, but it changes what data type it's considered to be pointing to. So now when I do that, it says, okay, you're pointing to an integer. and then it dereferences it. So this statement and this statement effectively do the same thing. And the reason is because this is pointing to x right now. So a void pointer is just a pointer with no specific type, and really the reason you would use it is if you wanted to change the type of it later. So if I, for some reason, wanted to change this integer to be interpreted as a boolean, I could cast the v pointer to a bool pointer instead, and then it will say, okay, now I know to only take 1 byte at a time from that memory address. Now, you wouldn't really use that too often, and it's kind of niche as far as where you would want to use it, because obviously turning an integer into a boolean is maybe a bit strange, and maybe not something you intend for. So I guess the simple answer is just it's a pointer with no type. The long answer is all this mess here that I wrote, where you can reinterpret your data in different ways. Just kind of like a generic type. Sure. Any other questions anyone had? I can pull open the list again too. Virtual functions? Yeah, we can do that. Right, so a virtual function was something that we could override, basically. So maybe I'll try to come up with a different example here than the original one I used. This operator? Yeah, I can do that too. So this operator and virtual functions. So actually, since assignment 5 is due tonight, let's use that as an example. So in the context of the program, we have the gadget type, which is gadget t, but I'm just going to call it gadget here to use a more consistent naming scheme. So we have gadgets here. And so a gadget is defined as having, and I'm maybe going to change the names here to maybe make it a little bit more obvious what everything does. But the gadgets really, they have a name, right, which is a string. So just assume that's a string. And they have the go gadget function, which I'll call use, maybe for the sake of simplicity. Perhaps I should put the type of that. So use here is virtual. And so what it means to be virtual, let's just put that there, I guess, is that you have the ability to overwrite it. So in this case, I'm going to inherit from the gadget. So gadget's not a very specific thing. It's kind of just, like a catch-all term. Like I can have several different types of gadgets, right? So in the context of your program, you have something like binoculars, and then you might have something like arms, and then, there's all those other ones that your gadgets.h program is generating. And so those inherit a name, and they also inherit use, but maybe you want use to do something different here in binoculars than you want it to do here in arms. So in this case, it just prints things, but maybe in the context of an actual program, you want binoculars to do something where it like pulls up sights or does some sort of calculation, and then arms does something completely different, like it plays an animation or whatever, if we had actual, graphical user interface and not just the terminal. So the virtual keyword here gives me the ability to override it later. Override. So I could write completely different code down here. And these would be different and do something else than the original one. So in the context of, I can pull it open here on the side. In the context of what we were doing as far as programming goes, we had that game. Oops, that's not good. We had that game, and that had a virtual function. So what I had here was we had that structure. It was a game object, and then we had a player inheriting from it and an enemy inheriting from it. And what was happening was I made a function. So this is the game object, the parent class to everything. So that, again, is not like a very specific description. Like, nothing in the game should be just a game object. It should be, something like a player or an enemy, something more specific in the context of your game. So what I was able to do is I was able to create something that was virtual, like, for instance, update here, which described what the object did on every frame of the game. So whereas a player might need to handle controls and do actions like jump or walk or whatever, in accordance to that on every single frame of a game, which is different code than what a game object needs to do. An enemy might just need to walk back and forth or like target a player or something like that. So they have different code, right? So in the context of this, the void here for player, it applied the gravity, and then it did the normal update that everything else did, which was just adding itself to the screen. And so the enemy here actually did nothing. And then we had like a walking enemy. So if we had another inherited thing, we had a walking enemy that every frame it would check if it's at a wall and then turn around if it hit a wall. So the enemy here, the walking enemy, does something entirely different with its code and its update function than the player does. But we want both of them to have it because they're both game objects, and we kind of want to be able to call it because they're game objects in the same way. So I had like a timer, right, or something that was based off of the controls in this case, where it updated every single frame. So the purpose of a virtual function is to be able to override the code so that you can make it do something different in a inherited class. So here, all of the objects in our game update in a different way because they need to do different things. In the context of assignment 5, these really just the go gadget function or the use function that I wrote here is virtual because they need to be able to do different actions. So the binoculars prints a different statement here than the arms statement, or the arms function does. Arms class, sorry. So the last thing I guess maybe to mention on that is what abstract would be. So in the case of the actual program, I believe this is marked abstract, which is done in C++ with an equals 0. And an abstract can only be done on virtual things. And in C++, I guess the terminology, and again, this is what they use on the test for the most part, is pure virtual. It means the same thing. Most other languages use abstract, but I guess C++ calls it a pure virtual because it lacks the word abstract in the actual syntax. And what this just means, right, was that it doesn't contain a definition. So this just forces these two here to actually override. So it forces them to do that override with the virtual part. So the virtual part allows the override to happen, and the abstract forces the override to happen. So virtual gives you the option, abstract forces you to do it. It means that it's just not defined at all. Now, one other thing I guess to mention is that when you mark any function as abstract. The class is also abstract. Oh, sorry about that. So this class is now abstract here. And what that means is that you are not allowed to make it. So I can't say like gadget A or something like that, make a variable of it, because I'm not able to use it if it has any abstract functions. And the reason being just if I tried to use the use function on it, it doesn't exist. So I shouldn't be allowed to make one because I might do something dangerous like try to use a function that's not defined. So the other term that I don't think I ever used, but that might be good to know, is that this function is also a purely abstract class. Or I'm sorry if I said function, I meant class. This is a pure abstract class as well, in that everything is abstract. So it only has one function, but it's pure abstract in the sense that every single one of its functions was abstract. So in C++, you're allowed to kind of do a mix of that. So I could always throw in a function here that wasn't virtual at the bottom, and that would be allowed. In which case, this wouldn't be pure abstract, but it would still be abstract. So when you say pure, I guess it just means that it's entirely that thing. Does that all make sense, or any questions on that part? Okay, I guess if you have any questions on it, let me know. In the meantime, I'll probably talk about this operator. So let's say I have a class called person, just for the sake of simplicity, and it just has a string name. Actually, let's just make this a struct. No big deal there. So struct person, it's got a string name, and then it's got a integer age. Okay, so I define some simple type, and then I go to main and I instantiate one. So let's just say I do. Actually, you know what? I need a function. Otherwise, this isn't going to work. I guess I'm going to have to erase this. So yeah, just say person string n int a, and then we'll change it in a little bit. Okay, now I think this is fine. So let's just say I go into main somewhere. So this code just comes later at some point, and we say int main, and then I make a person. We'll just call them P, and we give them the name H. Let's just keep it short, and then the age 4. And then I do person, and I'll call this one E, I guess. Spell out person, and then they have the name Tom, and 7. They're 7 years old. If I'm going to use a letter, I think Q is actually a name that some people go by, so let's just throw that in there. Let's say we're giving somebody a really short name. So now what happens here, right, is that this first one's going to call the constructor. So I'm going to go over to the constructor, and it's going to get called. I didn't actually write a body for it, so maybe that's a bit of a problem. And so there's some code here, right, that probably does some sort of assignment. So when I use the word this, it is referring to the object that called the function. And a constructor is a function, so a constructor counts as well. So when I'm doing this constructor, this one right here, this first one, where it has q and 4, and it goes to that code, this is p. And when I do it, when I call from this one, this is e. So this tells you who called the function, what object called the function. So in the context of the first constructor, that's the first person because that's the person who called the constructor. And the second one would be the second person because that's the person that called the constructor. So you can use that to tell who the person is that is calling and access any of their information. So it's not particularly useful yet for what I've written, but we could, tell in some way who is calling. Now, I guess I could always write something that does, actual code like p.function. If I'd written some sort of function here that does something, and I called it with, 7 or whatever, when I go to call that function, I can now get something like the name or the age by saying this name, this age, because it will know what object called it if you do that. Now, what the compiler doesn't tell you is that it always does this. So even if you don't put the word this, it's always putting it there. So if I was to write in this code, so if I went to the constructor and just did it the way we'd kind of expect it to be done, where, the string, that's the name, and the integer is the age. So I could say name n and age equals a, right? Now what it doesn't tell you is that if you don't put anything here, which you probably don't because maybe it's easier to read, is that it actually throws a this in front of it without telling you. The compiler will actually generate that. So when you write this, it actually says, okay, you mean this name and this age, the one that belonged to this object. So it knows to go and set that one and that one. This is age and this is name. Now it seems a little trivial for me to add it here, right? So I could write this name equals n, this age equals a, or maybe not trivial, but maybe a little overkill to go out of my way to write pointers, and that's fair. I wouldn't normally write it that way, but you totally could. So the reason you would use it for the most part, unless you want to do actual pointer stuff, which I'll pull up another example that we had from class in this moment, is if I was using the same type name. So if or variable name. So if I said string name int age, and I hadn't written this like I had previously, well, there's no name here anymore, or no n and no a, so I could say something like this and this. Now the problem here is, hopefully you realize that what this constructor should do is it should set this name and this age equal to this name and that age, right? But it has no way of telling the difference. So what name is this one? This will compile, but it won't do what you want it to do. What name is that one? Is it the person name or is it the function name? The parameter, the local. So is he class name? Anybody else think it's class name, or does anybody else want to argue for parameter? Or maybe do it with something that's not a constructor. So I don't see any other guesses, but that's okay. So this one is actually, that's that one. On both the left and the right, because it's the same name. And so the idea here is, that we have some sort of scoping thing. So I think the example I did before was just if I had int main, whatever, and then I wrote maybe a function up here that just was like void print, and it took an integer called x, and then I said int x equals 7, and then I said print x. Well, no, actually, sorry, let's do that a different way. And then I said print 4. And then I wrote down here, I actually wrote the function, and I said void print integer x, and then I said cout x. Now the question here would be what gets printed. So is 7 printed here, or is 4 printed here? Four, right? Yeah, you guys got it. So this will be 4. And then maybe we'll make that red so it's a little easier to read. So this prints 4. So why did it print 4 and not 7? There's an X right there. So 4 is parameter being passed in. Yep, right. So when I go down to this function, this X, yeah, overwritten, right? Or not overwritten, I guess, but it makes a copy and it has new information about what X means. It kind of keeps a table. I won't talk about it. It keeps like a data structure that keeps track of it. And you haven't gone over this at all, so it's just no worries about it. It's something that's we haven't really gone over the material needed to talk about it. But I guess I digress. Yeah, but you guys are right. So this would print 4 because it takes a copy of this, right? And this X only exists from here to there. And any other X that exists, it has no access to. So if I did something like this, where it took no arguments, erase that, then this, you should hopefully see, is a syntax error. Because X is not defined in this function, and it can't access ones that are outside of the function, right? But I guess the big point here is that when I do a parameter to a function, any name that I use exists in the context of that function, and it's the one that always gets used. So here it didn't even really have access to that one, but even if I had like a global called integer x up here, and I set that one equal to 7, this still would print 4, right? It always looks at the one that's in the function before it looks at the one that's in any enclosing scope, in this case, global variable. So, right, whenever you call a function, it always uses the new one that you've named. Now, where that applies here is if I have the name, which is a parameter to this constructor, which is in itself a function, the name that it uses by default is going to be the parameter one. Now that's fine, it does what we expect it to, but the problem is we still kind of want to use this one, right? That'd be kind of nice to have. And I could get around that by just renaming these to not match that name, right? Which you could always do. That's a programming practice that you could keep. But if you're like me and a lot of other people, you might want to just name it the same thing because the name makes sense. So the way we distinguish between those is using this keyword. So now, if I was to write the code, this arrow name and this arrow age equals age and name. Now it says, okay, I'm going to take this object's name, which is the class instance 1, because this is an instance of the class. You'll notice here, let's just say if I'm calling this one, then this is P, and P is a person. So I'm able to access its name, and it's referring to the person name, because P is a person. Whereas this one is the parameter. So this part now, I guess, just to highlight it, is now that part, and this one would be that part. And so it does what we expect it to. So you want to generally use this as a way to tell the difference between this calling object, which is an instance of the class that you're currently programming for, and a parameter. So does everybody understand why that works? It's because if we don't do it, it's just going to assign the parameter to itself, which, if you notice here, is just passed by value, right? There's no ampersand. So it's just going to make a copy of a copy, and then just, once you get to the end of the constructor, it's just going to die. So like in the program that you just wrote, right, you probably need to do something like this W equals W and this L equals L in order to copy the width and the length. And if you didn't put this, you would notice that you get some sort of seg fault or data access read error, or you would get some sort of issue where it just doesn't print anything because it initialized it to 0, because that's what your compiler might do. So it's very important when you're referring to an object instance to use the this keyword. So if you have questions on that, let me know. I'm going to pull open the other example that would be nice to use for this, which was also in our game here. So what my reasoning was when we were writing this program was that when I'm writing a game, pretty much everybody's going to have to interact with the player in some way, right? So enemies might need to know where the player is so they know which direction to like run if they're trying to chase the player. You might want to check collision with the player every single frame to see, if you're overlapping, and do something, or you might just need like the player health to do something different. You probably need the player a lot because that's the core focus of your program when you write a game. And so we could have a lot of other things like that where you maybe need a static reference to some specific object because you just use it a lot. So another example I would have is again, I've been writing apps for a little while, and I keep a static reference to the current user that's logged in because I kind of need their information a lot. And I have a user class that might hold other user information because there might be other users that you're interacting with that need to use the app, and so you can store their data, but you might not need it to be like there all the time, as opposed to like the logged in user. So I keep a static reference to that. So here I have like a static pointer to the player. And so what I need to do is I need to get that static reference to the player. And so the way I do that, just for the sake of easiness, is whenever I create a player, which we'll call the player constructor, right? It's going to go here and it's going to call this player constructor whenever I make a new player, is I take that static reference, which is to the player, and I set it equal to this. And since this always refers to the current object calling the function, what this code does is it takes this static reference that I have, this static pointer, static pointer out there, and it will set it equal to the player that just got created, which is this. So another way I can do it is if I want to keep track of who is calling or something important, I can say, oh, we'll keep a pointer to this thing. So here I say, okay, this is the object I'm talking about. It's this player, if that makes sense. So you can use this in a bunch of different capacities. It really just, it refers to the object who is calling the function. So generally you'll use it in the case that I wrote here, but you can definitely find other uses for it if you, if you're clever about it, you can find something to do with it. Right, any questions on that or any other questions that you wanted to go over? I don't think so. I haven't seen one. I'm probably going to post it soon. I have the next assignment already, but I don't think I'm going to have it be due this week. I think it's going to be the week after. That way you have time to focus on the test. At least I hope that's what we're doing. The assignment was called Assignment 7, so I think it's intended to be due on week 7. Any other questions? Even if it's on assignment 5, I guess. Does anybody have any questions? If not, I'll try to think of something. Alright, there's that again. I use C# for apps. Java is also pretty common for that. C# is nice because Xamarin Studio or Xamarin Forms is like a Microsoft owned API, I guess, for building like graphical user interface on mobile devices, and it's cross-platform, and that uses C#. C# is great. I encourage everybody to learn that or Java. I'm confused what the magic function does and how to call it in assignment 5. That's fair. That is a pretty hard part of this. So I posted that one picture. I think I sent it to you too. We'll take a look at that, and then we'll talk about what the magic function itself does. And I think that's, I guess, what we'll do here. So I created a thing here. So this picture should be up on the canvas now too. It's called Pointer Pointer. It just gives you a general map of what the actual memory allocation looks like if you do the code that I gave to last class, 2 classes ago. The one that did like multi-dimensional thing. So we'll come back to this, but this might be a helpful image to have. So the magic function, it creates a gadget pointer. So I'm just going to draw this in kind of a simple way. Let's just say I have the 2D array. Let's not worry about any of the fancy stuff of like its actual implementation where it's a bunch of pointers to pointers and all that stuff. So we just have like a 2D array. And so the idea was like this was 0, 1, 2, and this was 0, 1, 2, and then I had a variable called gadgets that was the 2D array, which is actually a pointer, but we're just going to, again, treat it like it's any normal array, because we kind of can. So this was the first, and this was the second. So these are the J's and these are the I's. Now what you want to happen in magic function when you call it is you want it to create a new gadget, and you want it to store into this array. So you need to call the magic function with a string, and basically what it will do is if this string, I think it's called gadget name, is binoculars, it will make a new binoculars. G equals new binoculars. Right, and so it does this for all of them. So it basically just checks, based on an input string, create an object that is a class that matches that thing. So if you give it the string binoculars, it will create a, what's it called? It'll create a class that's called binoculars. And if you read in arms, it will create a class of arms, and so on and so forth. So we have all these different gadgets, right? Binoculars, arms, copter, chopper, that kind of stuff. that are all just gadgets. And so it will create a new gadget and then assign it to the pointer that you gave it. Now, one thing I did realize, because I told multiple students this and I realized I was kind of wrong on it, is I said, okay, it's fine if you have spaces in your output file. And that's true about the classes, but I guess I didn't realize the fact that this magic function kind of breaks if you don't do that. So there was a problem with the actual input file where you would get extra spaces, and I had like, probably like 4 or 5 students ask about that, which is fair because it's kind of formatted a little strangely maybe. So you'll maybe want to remove that, I guess, just as a hint with this in your Skynet if you haven't already. I realized that might be an issue with the gadget name, so just something to consider. But anyways, this makes a new thing, right? It makes a new gadget. What I need to do is I need it to get placed in the correct location in the array. So I guess the thing that's been tripping people up is that G is a gadget pointer. But this is a gadget pointer. And this is what we actually want, right? This is an actual location in the array that represents like this cell or that cell or that cell or that cell. And so I've noticed that a lot of people are getting a little stuck on that, which is totally fair, because you might think well, I can't really use that space because it's not a gadget pointer, and the gadget pointer is a row. So if we go back to this image here, so I've done allocations where blue is the actual pointer to the whole 2D array, green is the rows, and then red is the individual elements. So you see here I allocate a 3-pointer array, and that points to all of these arrays, which end up making the 2D array if I kind of like visualize them together. So for the first index here represents the index into that array, and the second index here does that one. So the thing to note here is that I do need 2 indices if I want to access something like gadgets 2.1 or gadgets 1.2 or any of these over here, because I need both numbers to tell exactly where the square is, or the cell in that array. Now what I've seen a lot of students do in not only our section but the others, is that they tried to do gadgets I, rather than two indices, which would be a cell. They do gadgets I, which is actually a row. And this will be allowed by the compiler, and the reason being is because it is a gadget pointer. So when we go to these green ones, that is a gadget pointer because it's pointing to this, which is a pointer here, and then these are pointers. So the type matches. So it's semantically, so if we go back to what we were talking about earlier, it's semantically valid as far as the compiler is concerned, but it's not semantically valid as far as a human standpoint. It doesn't do what you want it to. And the reason that is because if I did, let's just say gadgets 2 here, what that does is it says, okay, gadgets, we go to the second one, which is this one, and this is the pointer it's returning. So gadgets 2 is this little green star right here, which points to this whole row. Now, that's not necessarily what I want, because that's not an individual cell, that's a row. Now the question is, why does it even let you do that then? Because why can I assign to that? It's not even a cell. Why is it allowed? So the thing to consider here is if I look at this pointer, this gadget pointer points to the beginning of this array. It points to this one right here. That is also where gadgets 2.0 is located. So when you pass just the one index or a pointer to an array, in any case, it will always point to the beginning. So when you call it with something like gadget sub 2, it will actually go and always use the first cell in that row. So when I use gadgets 2, it will always overwrite this little red pointer. That one will always get overwritten, which is not what you want. You want to do this one, and then that one, and then that one. So what you'll need to do is potentially do 2 loops, or you can use that linearization sort of thing, or like unlinearization, I guess I would say, with like the count variable that I did last time, where you count through the array like you normally would. So you do, for int I equals 0, for int j equals 0, or do the count and then change it. And then you now have the actual cell, right? So if I said like gadgets 2, 1, that's that one, which is good. I want to access an individual cell. Now the problem I think that's tripping people up with that is the fact that this cell, this red part, is a gadget pointer. And that doesn't match the magic function type. The magic function type is a gadget pointer pointer because of the way that it's written. So what we'll need to do is we will need to throw an ampersand in front of it, and that will get the address, or in other words, the pointer to that gadget pointer. So when I say ampersand gadgets 2, 1, gadgets 2, 1 itself is this star in the box. When I say ampersand gadgets 2, 1, that's the pointer pointing to that star, which is a gadget pointer pointer, which is fine. And it also points to the correct cell within the array, rather than the beginning of the array. So that's kind of the important part there. So I guess, long story short, you want to access the individual part of the array like you normally would. Just make sure you're getting the address of that thing so that it matches the type correctly. Otherwise, it's not going to work. All right. And with that, I guess we have reached time. But if you have questions, I'll stick around for a little bit longer. And if you have questions tomorrow, or just you think of something else, feel free to stop by. Office hours will be 12 to 3, like normal. Where's the list? It should be under announcements. It should be. I posted it right before the WebEx link, so it should be right there. It's also in the Discord, but I think it's a little bit shorter there. In the class discussion for section 101. 1001. And I'll try to get the lecture up soon. I'll try to upload all these screenshots if I can.